Okay, so let's have a look at number 10 in exercise 5.5. So let's have a look. It says the length of an arc is 8.9 centimetres. So there's our arc there, 8.9 centimetres. And the area of the sector is 24.3 square centimetres. So this area here in the yellow is 24.3. That happens when you've got an angle of theta subtended. So there's my angle theta there. All right, and clearly that you've got a radius for that circle, which we don't know either. So I'll just show you that there's a radius on that circle. So there's two things we know. We know there's a formula for arc, which is L equals r theta. And we know there's a formula for area of a sector, which is half r squared theta. So we've got two things to work with there. So 1, 2. So let's have a look at what we've got. We've got L is 8.9, so let's put that in the formula. R I don't know, theta I don't know. Let's have a look at the other one. I know A. Let's put that in there. So that means I've got 2 equations and 2 unknowns. So here's my first equation here, and here's my second equation here. So what do we do with 2 equations, 2 unknowns? We're going to solve simultaneously. So from number 1, I can make r the subject of that. So let's make r the subject here. So that means I've got to divide through by theta, which is why I've got r equals 8.9 over theta here. Okay, once I've made r the subject of that, I'm now going to put that into equation 2. That eliminates r, and I now have an equation with only thetas in it. So see that r? Let's go put it in there. So here it is. So once we've put that in, we'll square it. So 8.9 squared is 79.21. Theta squared is theta squared. Now I'm going to rearrange that equation. Do you remember I was telling you about how when you've got a fraction, if it's on the bottom, well, a fraction equals another fraction. So say you got a over b equals c over d. So you can swap sides, like the a and d can swap sides and the b and c can swap sides, or you can just leave them. That's the allowable movement. So I could do anything I like so long as I follow that movement. That only works when you've got one fraction equals another fraction. We had a look at that. So let's have a look at what I've done here. So I picked up my theta squared and I put it up here. There it is on the top, see? Because really, when you think about it, this is just a fraction. So I've put it up on the top. What else did I do? See this one here? I picked it up and put it down there. There it is there. What about that 48.6? I picked it up and took it down there. There it is there. So can you see what I did there in terms of swapping? If it's on the bottom on one side, it's the top of the other, etc. Okay, so I might just get rid of some of that busyness. It was just by way of explanation. I'll get rid of all of that. So that's how I've come to this line here. So theta squared divided by theta. Theta's not naught, so it's all right to do that. And now I've just got an answer for that. If you don't want to actually have that decimal there, you can always use this one here and sub that in everywhere, but I didn't. So back here, we knew that r was 8.9 over theta. So I'm going to use that. R equals 8.9 over theta. Theta I've just figured out. So I can sub it in and get a value for r. So now I've got r, yep, and now I've got theta, yep. I solved that simultaneously to get them. So now I'm going to use the area of a minor segment formula, which is just this one. We know that's the area of a minor segment formula. I'm just going to plug straight into that now that I know r and theta. Great, so whack them in. Get out your calculator. Try and keep as many significant figures as you can in the intermediate calculations so you don't introduce any error. If they only want this to 1 dp, you could probably just go to 3 decimal places in the middle of your calculations, but you've got to be careful with that. I included a lot. I've got 4, I think. And then my answer for area then comes out to be approximately 9.4. So that's number 10.